It's important to have a lab as a network playground. It's a space where you can experiment, learn, and build. Whether you're an aspiring network engineer, a cybersecurity enthusiast, or an enterprise architect, a lab empowers you to master the network fundamentals, try out new software, and test and validate ideas. Or even in our case, set up practical experiments and lab out things for customers as proof of concepts. In this video, I'm going to teach you how we set up our labs and show some practical examples of how we use it. Prerequisites for this video are understanding basic network concepts such as subnets and VLANs, also understanding a bit about virtualization. For this video, I'll be using pfsense, UniFi, and XCP-ng, but the concepts can be used the same way with other platforms as well, so let's get started. Are you an individual or forward-thinking business seeking expert assistance with network engineering, storage, or virtualization projects? Maybe you're part of an internal IT team that needs to proactively manage, monitor, and secure your technology. We offer comprehensive consulting services tailored to meet your specific requirements. Whether you need fully managed or co-managed IT services, our team is ready to help you. We specialize in supporting businesses that require IT administration or teams seeking an extra layer of support to enhance their operations. Our install team is ready to assist you with all of your structured cabling and Wi-Fi planning needs as well. To learn more about any of our services, head over to Lawrence.Systems.com, fill out the Hire Us form, and let us start crafting the perfect IT solution for you. If you want to show some extra love for our channel, check out our swag store with shirts, hats, desk accessories, and more. We also have affiliate links down below that'll get you discounts and deals on products and services we talk about on this channel. With the ad read out of the way, let's get you back to the content that you came here for. Now, a couple things that'll come up for debate right away. Do you start with a spreadsheet or do you start with a diagram? I prefer defining things in a spreadsheet and then moving on to the diagram. Next controversial thing is default management VLAN ID 1 from the head pfsense here. Go ahead and leave your comments on why you should never use VLAN ID 1 and what threat model that protects against. Always interested in hearing from you, but I think for a lab environment, perfectly fine to do it this way, but let me know what your feelings are on it because they may differ. And yes, of course, you could do this without setting VLAN ID 1 as the management VLAN, but we did for this particular video. Now, from head pfsense means the pfsense that comes in and brings the internet to the network. The gateway and network for that is the 192.168.86.1/24. Technically, the network denotation would be 0.24, but the gateway is .1. That network does have DHCP, and that's where I have things like the UniFi switches and the XCP-ng hosts themselves, along with the NAS servers. So all the things that are made for managing this particular network. From there, we have VLAN ID 20, don't route storage. I do not define this VLAN inside of pfsense. The next slide will explain a little bit more on where all the VLANs are defined and where they're not, because we don't need to define the storage VLAN in pfsense because there's not a need to route storage. I generally prefer storage to be a completely separate VLAN. A lot of times I'll just take ports and assign them storage only, and then each address via static IP. And that's it. That's how I document and build my lab. I don't even want a DHCP server handing out for storage. I have a whole video though, Lawrence.Video/StorageDesign, where I dive deeper into all the different ways you should set up storage and suggested ways to get around the need to route storage. There may be exceptions where you need to route it, but generally speaking, avoid that unless it's just absolutely necessary. The next is the lab default, the VLAN 100 and 10.69.100.1/24. This is DHCP and coming from the head pfsense. So this VLAN is defined in pfsense, and that allows it to hand out addresses, and the rule set is really simple in pfsense. It allows internet access, and that's it. It can't laterally move. It can't talk to any of the other devices on pfsense. The pfsense and this case is actually used for a few other things, but I'm narrowing it in scope to just the lab portion for simplicity here. The next ones, lab 101 through 110, are referred to as floating. I assign these, and I'll show you how that works in the practical side of the video here, to all the different interfaces so I can build out networks with a virtual pfsense. I can match client network design and match IP ranges of things I may have to set up both virtually or physically out in the lab. This makes it so much easier when you want to deploy something for a client or build out something and have a virtual network that you define on the fly as needed. So lab 101 through 110 are not defined at all inside of pfsense because they don't have to be, and pfsense on the head end side has nothing to do with it. Then we have WAN Lab 1 and WAN Lab 2. You may have seen these from previous videos. We use this to assign two different interfaces on our virtual pfsense. This allows us a really simple way to take pfsense and assign on what you would may be perceiving as the LAN side, public IP addresses that belong to our clients. For example, if I had two firewalls and I would like to set up a VPN between those firewalls and I want to do it in my lab prior to shipping it to the client, we can actually assign the client's IP ranges of their public ranges inside there on the WAN lab and then plug their firewalls into the ports, and it will allow us to completely set the VPN using their static IPs. And you may wonder, well, does that actually work, and can you route that way in pfSense? Yeah, I'll show you how. It's really simple. Second, it also does break your ability to talk to the client, which is why we use a virtual pfSense for it. So when I get to that part of the video, one of the big reasons I use a virtual pfSense is that way, if the firewall that's at the head end is also being used to communicate at all with the client because of other things that may be attached to our networks, if you set your static IPs on the essentially LAN side of a pfSense, you can no longer get to that client from that network because you're connecting locally to those IPs, and you will break the ability to route over the global internet. So it's specifically designed for lab setups and not for actually communicating back to the client, this is why we set up this particular pfSense virtual. Then the last one we have is defined in pfSense, and it's just CGNAT. Now you notice it's a 164.43.33/27. I don't like to use all of the CGNAT range just in case I have to contact or something we have to communicate with is also in that range. And I never have that many firewalls plugged in at once. But by putting this rule in here along with this network range, I know all the firewalls just get assigned CGNAT. And if I'm just testing a bunch of firewalls and I want to do some videos with them or just test 5 of them and build my own little internal VPN, I can have them all CGNAT addresses. I can immediately see that range of addresses and go, yeah, those are the ones that belong to the firewalls that I might be setting up on the network. Next, that is a rule that is well defined inside here, exactly the same way as the lab default rule, where you have the pfSense able to provide internet on that network, but nothing else. It doesn't have access to the management interface. It doesn't have any lateral movement between any other piece of the network. So lab default and CGNAT are just the really basic pfSense rules that say allow them to hand out addresses. They're both set up at DHCP and get out to the internet, but that's it. No, they can't talk to each other. Now I'll drill down deeper in the next few slides, but you can see I only have these couple VLANs defined on the pfSense, and then UniFi and XCP-ng have all of them defined. What this allows me to do is use the switch ports. So I say all VLANs from pfSense. The all is the terminology used by UniFi. Trunk is a common one that would be used in the Cisco and other Cisco-like setups. But this means all the different VLAN tags come from one single port and go into a UniFi switch, which also uses the all or trunk. So it means send all the VLAN data over to here. Now there's obviously more of them defined in a UniFi switch. If you don't define VLANs in a UniFi switch, and this applies to many other switches as well, they won't transport unknown VLANs. So if you were to just plug something in that's using one of the not defined VLANs, well, it may not transport it. So you do have to implicitly list them. And if you're wondering if there was ever a point in time years and years ago where UniFi used to not be that way, that's correct. They used to have a traverse whatever traffic went across them. They have since changed that here in 2024. Now, then it goes down to, from there, our XCP-ng host, which I said has all the VLANs defined, but then we have VLAN 20. I will assign ports specifically VLAN 20, and then the NAS and storage system will also have VLAN 20 assigned. Now, I didn't draw the line here, but if I'm doing admin work on NAS and storage, you would also have seen a management VLAN attached to the NAS and SAN storage, because that is where all the IP addresses for management would live for managing the XCP-ng host and the NAS and SAN storage on here. But this is just an overall concept of it. Now, as I pointed out, when you're looking directly at pfSense, those are the only two VLAN tags that needed to be defined in here because I'm using the native one for the management. When you look inside of UniFi, here's all the list of VLANs that are in here, and because we're not using a UniFi firewall, they will all just show up as third-party gateway, which means not UniFi for the firewall or the routing. I prefer pfSense because it has such an extensive amount of features. UniFi has become much, much better in the routing, but it doesn't have 100% of the features as matched in pfSense, so I continue to build it out this way. And here is the kind of truncated view. I'm not showing all of them because this would be several slides, but this is where all the VLANs are defined in the pool. When you define things in a resource pool in XCP-ng, every host that's in that resource pool has them as well. So if I add lab 101 to the pool, all hosts in that pool get this. This is how the resource pools work in XCP-ng. This also means all the virtual machines have access to any one of them I define across the entire group of pool. So if I have 8 hosts in there and they're all tied to one pool, I only ever have to define these once, and they automatically are on all systems and available the same way. Now let's drill down a little bit further. We have the internet coming into our main pfSense, the UniFi switch, the XCP-ng host, and then I have a virtual pfSense running. XN0, which is the first virtual interface on there, virtual interface 0, and you can see the names line up, that gets CGNAT. So this is the CGNAT that's assigned to this particular firewall. This also makes it nice when I add other firewalls, especially real-world ones. I have a virtual pfSense, so I can do things like test interoperability between this pfSense and maybe a site-to-site VPN with a UniFi firewall or any other one that I want to test. I just throw them both on CGNAT network. Then from there, we have it attached to Lab 101, 102, 103. I can continue with this and add more of them. This is generally enough for our use case, but this is why there's so many lab ones. This is why they're floating. As needed, I define them in this pfSense to the network ranges that work for me, whether it's defined because of a client or just because some range I wanted to pick for some testing. This allows me to start building out that virtual network, and then all the things I attach to it will work in that same virtual network, receiving everything from this pfSense. And then the WAN Lab 1 and WAN Lab 2, once again, we can apply them virtually. Usually we're applying them physically by assigning them to a port. For example, if I set up Lab 101 and I want to build several Windows VMs, absolutely, I can do that. Maybe on the same system, I want to build some Linux VMs and put them on Lab 102. And then I can go through and start building out all my rule sets. And this is also where training comes in, of understanding how rules work, where I would build these out and maybe have some staff or even myself, or when I'm making a demo video or a proof of concept for how a rule works, because I want to display something or test an idea someone has, I can take these and see how I build the communications between them and build out all the rules and do it all virtually. Doing this virtually also has the advantage of doing snapshots. So I can snapshot, try an idea, and just revert back to however it was set up previously. Now let's talk about how we bring those WAN lab connections to the real world to set up real world firewalls. So you do when you're setting up WAN lab and you know the client's static IP information, you know what their gateway is, and you know what the IP is assigned to their router. And you simply assign that gateway to what you're going to perceive essentially as the LAN side of pfSense. So you have the WAN still a CGNAT on pfSense to bring internet in, and it's a CGNAT address, so I'm not worried about any conflicts there. Then we have the XN4 and XN5, which I'll define as the gateway address for whatever the client's routable network is. So we'll take that gateway, assign it, and then we can give each one of the firewalls their actual IP address that they would receive when they are installed at the client location, whether that be a data center, their office, a fiber line that has been provided by their ISP. We'll just mimic all of that internally for setting things up. And then you go inside of UniFi and simply assign the port, the WAN lab port, and then we'll do something so we can put services, if needed, behind the firewalls, because you don't want to just have a site-to-site VPN and know the firewalls can talk to each other. I usually put a couple of virtual machines behind there and make sure they can ping back and forth through the firewalls and go through the site-to-site tunnel. But this allows us in our lab to completely stage exactly how something might be set up in the data center in the client location prior to shipping it to them. This is what it actually looks like when you assign a port. I'll name it the client name, WAN, or maybe site A or site location name, and then I'll put like WAN Lab 1 has a VLAN ID of 300, and then I'll do another port and do it the WAN Lab 2, which has a ID of 301, and those physical ports now will work and talk to each other and be routed through pfSense. With the pfSense, I generally just leave wide open rules on that because I don't want anything interfering. Those rules for the WAN Lab are just no rules essentially, other than allow all, because the goal is to get them to route and communicate with each other. And this is a closer look of how that looks when it's plugged in. So it's literally just plugged into each of those ports, matching the ports on the particular firewalls that you're using. And for those wondering if you can do this with Wi-Fi, absolutely. You can even take external firewalls, use some of the lab IDs, and use the Wi-Fi through there. So you can actually have a Wi-Fi that it goes behind the virtual pfSense, or can even go behind one of the other firewalls that you have out there and plugged into the ports, just by assigning the ports that way. Now I want to start here in Zen Orchestra. That is a tool that manages the XCP-ng hosts and XCP-ng itself. We're going to zoom in a little to make it easier to see. So if things look a little big, that's because I zoomed in. We have our WN12 lab and our pfSense lab. If we just expand these out, you can see the different addresses assigned. So the WN12 lab has a 10, 69, 100, 100, And then the pfSense lab has the CGNAT address for the WAN, and then a series of other addresses we have attached to the interfaces. So let's go and start with the Debian system, and we have the network. And this comes from the headend pfSense, as noted earlier in the video with the diagrams and the VLAN list and the network list. This is the default network that's added to any new VMs. So if I go here to create a new virtual machine, no matter what template I select, it automatically will fill in with this lab interface, and I can add more of them. And if I need to, they're easy enough to change. Going back over to the Debian virtual machine, if we want to put this behind the pfSense, we can go here to Network, and we know the pfSense is attached to Lab 101. So let's go ahead and switch it. And this is all being done in real time. It will get a new IP address that fast. Now we're at 10.1.10.109. So if we go over to our pfSense, which you can see the interfaces over here, and if we go over to Services, DHCP Server, and look at the leases, we can see 10.1.10.109, and it's called our Debian 12 lab. The other networks available on here are also lab 102 and 103. And I can just as easily go back to our Debian 12 lab and choose any one of those, such as lab 102, and it will get an address from the pfSense in the lab 102, which is the 192.168.197.100. And if we go back over to our DHCP leases again, we can see the 192.168.197 and the Debian 12 lab assigned to it. Now let's talk about the WAN lab. So if we go to WAN lab 1 here, we can see it has a IP address of 203.0.113.1. And we've set this up as a /24 because this is referred to as a demo address used for examples. Go ahead and look this up. It's not actually a real public IP address, but for the purposes of demonstration, I want to show how to set this up and configure it. And you notice there's no upstream gateway. You can assign a valid public IP address to an interface on pfSense and not assign an upstream gateway and use it as the gateway for other services. This is where we'd be plugging in other firewalls to do what I had said about doing a simulation. And we can go back to our Debian 12 example here. And if I assign this to WAN lab, and this is because I actually have DHCP turned on, it's optional, it'll get an IP address in that 203 range. So now it's 203.113.10. But this is how you can start taking entire blocks of public IPs and actually just hand them out via pfSense. It'll work that way perfectly fine. And as I said, this is a frequent way we use it in order to set things up for clients. Now let's talk more about how we physically will cable things to this little UniFi mini switch. And for those of you that are wondering, yes, this does support VLANs. There's always some confusion because it doesn't support certain VLAN features, but for the basics and what we're going to be doing here and how this works, we will be using just a standard original Flex Mini. Obviously, the new one would be a better purchase today. I just happen to have a couple of these and they work well. This is for a future video I'm working on to do a site-to-site VPN. And what we have here is the red cables are assigned labeled Site A and Site B. That's the names I was going to give these firewalls here. Now these Netgate 6100s will be part of a demo for doing a WireGuard site-to-site tunnel, and how I want to do that is assign CGNAT to these red cables here for the Site A, Site B, but then I need devices behind there. And I could plug in physical devices and build a network, but it's easier to take these black cables here, assign them Site A, Site B, Lab 104, Lab 105, and then put virtual machines behind them that work behind each individual pfSense box that I have here. This is a way you can blend, so to speak, the physical layer and the virtual layer together to be able to do these setups. Now, I covered everything and focused on the lab in this video, but of course I have full tutorials on pfSense, XCP-ng, and UniFi that you'll find playlists for down below, because there's a lot of concepts to cover that led me to where this lab is set up today, and those different playlists will hopefully help you with your journey as well. Now, some people may be asking, can this be done with Proxmox or can this be done with other switches? Absolutely. Everything I described in this video can be set up with Proxmox as well. I just don't use it. I prefer XCP-ng. It's my favorite open source hypervisor platform. We use it commercially. We support it commercially with a lot of businesses, and I do like using it in my lab, but Proxmox is valid as well for those of you that would like to use it. And there's plenty of other people doing Proxmox videos. Next is the switching. I do love the way UniFi does it, but if you wanted to do this with Cisco, MikroTik, or something else that you prefer, the concepts still apply for anyone wondering. As long as you have managed switches that support VLAN, trunking, tagging, etc., you can use them to do it. You don't have to do this in UniFi, but UniFi is a pretty good option, in my opinion, for doing this, and it's really trouble-free for the scale that we operate at. A few other questions that always come up is, who does your diagrams, Tom? And I do them, and where can you find them? On my GitHub. I use a tool called Draw.io. It's also free and open source. And before I even upload these videos, you'll find that I've uploaded the file that I use to create the diagrams in any given video is over on my GitHub. There's a lot of them in there, and it really helps you with that blank template syndrome of, I need to create a diagram for something, but I don't want to put the first thing in the wrong spot. So just start with one of the templates. Matter of fact, if you notice there's a common theme, I frequently reuse my templates and rearrange them myself. So even though there's a variety of them up there, you'll find them very similar to each other, but they're all free. Go ahead and download them from my GitHub. Now, if you want to ask more questions about this, leave your thoughts and comments down below. Love hearing from all of you. But if you want a more in-depth discussion where you can put a lot more information and have more interaction with me about this video and other topics, head over to forums.lawrencesystems.com, because the forums are where I spend a lot of my time. I like helping a lot of people out there, and I'd love to see you join in the forums as well. Like and subscribe to see more content from my channel, and head over to lawrencesystems.com to connect with me on whatever socials you'll find me on there when you're watching this video. I'll see you online, and thanks.